Hello, good evening, everyone. I hope I am audible. I welcome you all to GRE Preparation Made Easy Quantitative Reasoning class by Mrs. Annapurna Murugan. Here are a few instructions for the participants. Make sure you have a stable internet connection and a noise-free environment. We recommend you to use your earphones for best experience. Also, please respect your instructor and your classmates. Do not write anything inappropriate on the chat box. Also, how to answer the polls. You have to click on the more button where you see activities and you'll go to polls. We have three packages, that is bronze, silver, and gold. If you upgrade to silver and gold, you will get extra benefits like evaluated mock tests, expert university recommendations, dedicated counselor for entire application process, and so on. We also have free profile evaluation with our experts, comprehensive evaluation, university shortlisting, course recommendation reports, and doubt clearance. We also have three free live IELTS classes, that is Monday to Friday, 7:30 to 8:30 p.m. It is a 4-week course. And Duolingo classes Monday to Friday, 6:30 to 7:30 p.m. It is a 2-week course. You may enroll for free. Here are a few achievements. This is the Ubergrad website. You can select the country, course, and specialization. When you go and explore, we have countries, universities, courses, and exams. You can get all the information from here. When you go on solution, we have free profile evaluation, talk to the counselor, country recommendation, course recommendation, test preparation tools for IELTS, GRE, and Duolingo. Additional services are provided as well as weekly blogs are uploaded. You may go through them. To contact us, you can call us, WhatsApp us, or mail us. Also, when you go on My Test Preparation and click on GRE View Course here, you will be directed towards the handouts and recordings. In case you've missed any sessions, you can get the handouts and recordings from here. Also, for any other query related to the Ubergrad website or handouts and recordings, you may ask at the end of the session. Have a great session. Thank you.
Hi guys, good evening. I hope everyone is doing good. Okay, so let's start off with the session. And today we are going to discuss triangles and as well as polygons. Okay. I guess like yesterday, you people had uh, a few basic things about lines, angles, triangles, and all of these things. So now let me narrate a few more important things about triangles. Okay, so I'm going to present the screen. So whenever it is required, you people can basically ask me this one. You people respond to the questions that we give, and you can have all the queries at the end of the session so that we can answer the same. Right? Okay. So here we go. I'm going to present the screen. Yes. I guess everyone could see the screen. Let me put it. It's showing the present view. Right. Triangles, you people understood few things about triangles. Okay, I'm going to start off with the things that were left over yesterday. Okay. Now, yeah, angles and side comparison. I guess you people done. So similar triangles. So here we are going to discuss about similar triangles and congruent triangles. So what I do is let me take a whiteboard and explain to you guys what do we mean by similar and so your congruent triangles. Okay. So and few more properties about the same I'll be telling you guys. Let me take whiteboard here. Yes. I guess everyone could see the screen. First of all, I would like to speak about congruency. Okay. So congruency of triangles. So not only triangles, any figures can be considered to be congruent. So what do we mean by congruent? So congruent is nothing but exactly same size, same shape. So it's same. Okay, so it's completely same. So then we can say the two shapes or two figures are said to be congruent. So when we are going to say them as, or when we are going to declare two things, okay, not just triangles, I'm talking about two things, when we say them as congruent, when we keep one upon the other, okay, we should not have any extra spaces, it should completely coincide, okay. So when they coincide together, so then we can say that the two figures are congruent. For example, so if I take a triangle ABC and I have one more triangle DEF, when can I say that these two triangles are congruent? If I overlap them, say if I take ABC and if I place it on DEF, so it should be like exactly ABC. We should not have any extended sides or any extended angles. That means what? So the corresponding angle should coincide, should be equal, and the corresponding size should be same. Okay, so exactly same. So then we can say it as congruency of triangles. But when we can talk about the congruency, when we can prove the two triangles to be congruent, so we can prove two triangles to be congruent. So by a few important laws. So what are those important laws? Miss, first let me say, or let me take triple S law. What we are going to take? So triple S in the sense, if the corresponding, if all the three corresponding sides of two triangles are equal, so then we can easily say that, so the both the triangles are what? Congruent. For example, if I say AB is equals to DE, AC is equals to DF, and BC is equals to EF. Okay. So, if all the three sides are equal, then I can say that the two triangles are congruent. So, how can I say two triangles are congruent? So, we all know one thing. The side varies according to the opposite side will be equal to opposite angles. That means, so if I say AB will be, what is that? Corresponding AB will define the angle C. Okay. And here if you see, DE will define angle F. That means if they both are equal, so then these two should be equal. That means from this we'll come to know angle C is equals to angle F. And AC defines which angle? Angle B. And so DF defines which angle? Angle E. So therefore I can say angle B is equals to angle, this one F here. Sorry. So this is angle E. So like that only. Now this becomes angle. BC is opposite to angle A. So this will be defining this. So therefore what? From this, if all the three sides are equal, so then even their angles, the corresponding angles will be equal by default. Okay, by default, the corresponding angles tends to become equal. Hence we call, so hence we can take, if we have two triangles, if their corresponding sides are equal, then we can say that the two triangles are what? Congruent. Here what we can say? We can say that they are congruent. Remember, congruent means exactly same. Okay, don't get confused with similar. Then now you may be wondering, ma'am, so if SSSS is there, so if all the corresponding sides are equal, then It implies if all the corresponding angles are equal, then we can have the triangles to be this one congruent. See guys, if I have, what is that? A, B, C. Okay. So if I have something like this, 60 degree, so 70 degree, and 60 plus 70 is 130, so this is 50 degree. This is the thing. I can have a triangle of the same angles with different, this one 60 degree, 70 degree, and 50 degree. That means what? We can have the angles same, okay, but the side length varies. Okay, let me take a simple example. So 60 degree equilateral triangle, okay, 60 degree, 60 degree, this is of say 5 centimeter, 5 centimeter, 5 centimeters equilateral triangle. I can build one more triangle, isn't it? So of equilateral triangle, so which is 60 degree only, equiangular triangle. So where I can say 6, 6, 6. But can we say these both as congruent? No, right? So they can be similar, but they cannot be congruent. Congruent means what? Exactly same. Hence, so triple A postulate we won't be using to prove the congruency. Never ever take that if all the corresponding angles are same, so then you cannot randomly say that so they are congruent. Okay, so don't take this ideology to prove your congruence. So now let me take one more this one, that is ASA postulate. So according to ASA, if two angles, and one included side, side is same, then we can say two triangles are congruent. For example, I have something like this. Let me take two triangles, A, B, C, D, E, F I have. If I say angle A is equals to angle D, and angle B is equals to angle E. Okay, that means angle A is equals to angle D. Okay, so now angle B is equals to what? Angle B is equals to angle E, and along with that, if I say AB is equals to DE. Okay, that means if I say this side is equals to this side. Okay, so then this angle, this is the first angle, this is second angle equal, and the third side also it is equal. So then I can say this as what? Congruent. The given figure, the two figures are congruent. So why it is congruent? You know that this angle is equals to this angle. That means opposite side of this can be equal to opposite side of this. This is equals to this angle. So opposite side is same as this. Okay. But now what we have? So this side is equals to this side. This implies what? This angle also will be equal. That means, so three corresponding angles get to equal. That means if you see two angles and if one included side, okay, you need to always add this included side. You cannot take this side or this side. Okay, only if you have this included side. So then we can say it as what? We can consider that by ASA congruency, we can say that the two triangles are congruent. Okay, so now let me get on to one more thing. SAS. That means what? Two corresponding sides and one included angle. See, why I am saying that included angle means, in this case also, why I said included side. For example, if you had angle A is equals to angle D, angle B is equals to angle E, but if they say that instead of AB is equals to DE, if they would have said AC is equals to DF, if you get to prove AC is equals to DF, so then by this thing, okay, you can't say these two triangles are congruent. Why? You're not proving that this side and this side is same, or you don't have any proof that this angle and this angle is same, isn't it? So what happens? That will not work out. Always, if two angles we are picking, the included side should be same. Okay, remember, while you people prove also, you should have this thing, the included side, not the sides whose angles are already equal. You cannot pick already the sides whose angles are equal there. Okay, in the same way, if two corresponding sides are equal of two triangles and one correspond the included angle is same, so then we can apply the same rule and we can take it. That means what? If I have a triangle ABC, and here we have one more triangle, so DEF. Now, what is that? According to SAS, if AB is equals to DE, AC is equals to DF, if included, which is the included angle between these two corresponding, this side, this side, this side, this side, they are correspondingly equal. The included angle is which one? This angle. If we have angle A is equals to angle D, then with this data, we can say that the two triangles are what? So congruent. Okay. Now, one more thing we have. RHS. We use the RHS and we prove what is that? The two triangles are congruent. Okay. So what are we going to do? We use RHS and we are going to use this one. So here what happens? One angle. RHS means what? Remember, one right angle we have. Yes, we can see ABC is equals to angle DEF. This is one. Hypotenuse will have AC is equals to DF. And if any one side, okay, if any one side, if you take either BC is equals to EF, or so if you take AB is equals to DE, then we can say that so it is the two triangles are congruent. That means basically how many this one postulate we have to prove congruency. One is triple S, remember, the other one SAS, then ASA, then RHS. Okay. So these are the four major postulates, so which we can use to define or which we can use to prove the congruency here. Okay. So now simultaneously I'll be talking about similarity. Any doubts till here, congruency, guys? See, because I'll be moving on to similarity. So any doubts we have? No doubts. And one more thing I want to say, the two congruent triangles, two congruent triangles, if we have two congruent triangles, then you should know that the areas of both the triangles will be same. Both triangles will be same. Okay. Don't wonder, oh, if two triangles are there, so if they are congruent, what will happen to their areas? Their areas also will be equal. Okay, their areas will be equal. Perimeter will be equal. Remember that. Okay. So that's the basic thing about our congruency thing. It's not just knowing how to prove the congruency, but features also you people need to know. What is this congruency? Congruency means both triangles, because it's the same triangle only. Okay, congruency means what? You're talking about two same triangles. Obviously, what happens? The areas and the perimeters also remain same. Okay, just clear. When they give the option, compare. Okay, this is the two triangles ABC and DEF we have. They are congruent. Area of ABC, then area of DEF. So now, what you need to say? You need to pick up the C option, which is nothing but they both are equal, isn't it? So that's the thing you people need to keep in mind. Even the perimeter also. Okay? So now, let us talk about similarity. What do you mean by similar? Many times you will be seeing people will come and comment, oh, you look like your mom, you are similar to your dad. So, or so we had the similar experience. All these things they say. When it is like language, similar in the sense what? So it is not exactly same, more or less. So they had the same kind of experience, more or less, I'm saying. That means, yeah, in to some extent it may be same kind, but not exactly. Okay, that is similar. If we say you look like your father, you're similar to your father, if we say, what does that mean? There are some features so which may be same like. Okay, so that is similar. Exactly same means what? We need to say you're congruent to your father or you're congruent to your mother. That means same, exactly, ditto to ditto, identical twins we can take. Okay, so that's the thing. Here also, when we are talking about similarity, to look, they appear same, but their size may vary. Okay, but their size may vary. To see, they are similar. How we can prove the similarity? Okay, how to prove the similarity? We need to have two important ideas. Okay, see, for any, it is not only triangles, guys. So any figures can be proved for congruency and can be proved for similarity. So for any polygon to be similar, so you need to have two conditions. One is what? All corresponding, all corresponding sides of two polygons, two polygons should be same, should be same. And along with that, so what we need to have? Corresponding, all corresponding sides or corresponding, sorry, this is all corresponding sides. This is angles, guys, corresponding angles. All corresponding sides of two polygons should be in equal proportion, should be in equal proportion. That means the ratio of the corresponding sides should be same as the ratio of the other two corresponding sides. Okay, these are the two conditions. That means angles should be exactly same. Along with angles being exactly same, even the corresponding sides also should be proportional. Okay, so the corresponding sides also should be proportional. This is for what? Our polygons. But when it comes to triangles, we have one simple thing. If the two triangles corresponding angles are same, then we can directly say that they can be, what is that? Proportional. I mean, the sides of those particular triangles can be proportional. For example, so this is one of the exemption. It is absurd here. Okay, it is naturally absurd that if we have A, B, C, D and D, E, F, DEF. If angle A is equals to angle D, angle B is equals to angle C, angle E, and angle C is equals to angle F, then it is observed naturally that, so when we take AB by DE, this side will be proportional, this ratio will be proportional to AC by DF, which is again proportional to BC by EF. Okay, that means what? Since the size, corresponding sides also proportional, the ratio of the corresponding sides also proportional, and the angles are also equal. So we can say what? These two triangles are similar. What we can say? These two triangles are similar here in this case. Getting it? That means what? How can we define so that the two triangles are similar? Means if their corresponding side angles get equal, then it is naturally observed that their corresponding sides will become proportional. If their corresponding sides become equal, then we can say what? It is congruent. But if their corresponding sides get the ratio of the corresponding sides get proportional, so then we can say that so it is similar here. Okay, so this is what we basically have in this case. So depending upon this, so we get the conclusion that, or we see that one of the important thing, so ratio of corresponding sides. See guys, this is very important when we are doing corresponding sides will be equal to ratio of corresponding what? Sides will be equal to ratio of the corresponding heights, which will be equal to ratio of corresponding angle bisectors, angle bisectors, which is again equal to ratio of medians, which is again equal to ratio of in radii, ratio of in radii. That means these are for what? Our similar triangles. And also this will be equal to ratio of circumradii as well of two triangles, which is also equal to ratio of perimeters. Perimeters. And so this will be equal to the ratio of, what is that? That means ratio of all these squares. Okay, ratio of areas of two triangles, similar triangles, will be equal to what? Ratio square of ratio, these all these things, corresponding sides. That means, so area of triangle ABC is equals to area of triangle DEF is equals to what? AB square by DE square. Even their altitude squares, median squares, it will be equal only for areas. Okay, this thing you people need to remember when you are doing your similarity. Okay, now we have one Thales theorem, which is also called as basic proportionality theorem. What we call it as basic proportionality theorem, which basically comes out of this. So what do we see here? If I have a triangle ABC, and if I take point D and E on AB and AC, if I draw a parallel such that D lies on AB and this one E lies on AC, then you will be seeing that, so these sides, the triangle is divided proportionally. What we can say, the triangle gets divided proportionally. That means in the ratio m is to n and m is to n, it will be there. Okay, so that means what? I can say AB by DB will be equal to AE by EC, which will be equal to AB by E. Okay. So that is what we can take it up. AB by DE. So which will be equal to AB by DB. It is already given. So we can say AC by E. Okay. So this is how we take. And also if you want to find the length of DE, okay. So if BC is there, if you want to find the length of this parallel line which is parallel to BC, it is nothing but you can take it as M divided by M plus N times the length of BC. What is that? Your DE will be equal to, okay. So DE will be equal to M by M plus N into BC. So these are some of the things that we have with regards to our similar and this one. Now let me take the worksheet here. Yes. See, whatever I explained, it is all here. Okay. So now guys, so take this and solve it. Now tell me, who want to do this? Can I use pen? Huh. So now this is the thing we have. If the line segment with length x is parallel to the line segment with length L. Okay. So what is the value of x? Let me name it as A, B, C. And this is D, E. Now guys, give a try. Just now I said something. Basic proportionality theorem. Use the basic proportionality theorem and find it out. Just give me 1 second. Give it a try. Just give me 1 second. Give a try till that time. Yes. Did everyone give? What is the length of D? It's a simple basic proportionality theorem we are going to use. Answers, guys. Message me. Not able to do? No worries. What according to this? So from this I can say DE is parallel to BC. And if you see the sides also. So first you need to find out whether it is similar or not. If you see AD by AB, if you take, so should be equal to AD by DB. Okay. So, like you can see here, what is happening. So they're all proportional, isn't it? So if you take the entire length and if you take this one, see 2 by, just give me 1 second. Eraser. So what is that? 2 by 8, we have 2 by 8. If you see correspondingly, so it is 2 by, if you take the entire thing, AD by, so AB should be equal to what? AE by AC. What is AD? 2. AB becomes what? 2 plus 8, 10 is equals to 2 by 10, which is 1 by 5. 1 by 5 is equals to 1 by 5. That means these two triangles, that means this triangle and the big triangle, they are proportional. If they are proportional, that means we also see that DE by BC also should be proportional, isn't it? DE by BC also is proportional. So if it is proportional, then it also must be equal to 1 by 5. So what is BC? BC, though they have given 11. So DE will be equal to what? So 11, you take it up by 5, which is nothing but 2.2 you're going to get here. So that means DE is nothing but your X, right? X value is what? 2.2. So if you get, and you take, you try to find this. So 2.2 divided by, what is that? 11. It comes 5, this one 1 by 5 only. So that means that's a proof, that's a verification that these things are this one. Okay. So, and so this is how you people can find our this one. So, and even you can use the formula m by m plus 1 n into the this one. You can use m by m plus n into, so BC. Okay. So if you use that, so there also what you will be getting, so you will be having the same thing. Okay. So next one. In the figure above, DE and AC. DE and AC are parallel lines. If AC is equals to 10 centimeters, DE is equals to how much, guys? 6 they have given. And CE is equals to 2. What is the length of side BC? So they are asking what is the length of side BC. So find it out, guys, what it should be. So consider the two triangles. Triangle BDE and triangle ABAC. That means, so they must be, because this is parallel. That means what? You will be seeing that they are similar here because we have one angle also. What is that? So common to both of them, and this is a parallel line. If we have a parallel line, obviously their sides are proportional. That implies what? So we can say DE by, okay, so DE by AC will be equal to what? BE by BC. What is BE? X. And this BC is what? X plus 2. So you people can equate. Now DE is what? 6 by 10 is equals to X by BC is what? X plus 2. Cross multiply and get this one. So you'll be getting 6x plus 12 is equals to 10x. So that is nothing but 12 is equals to 10x minus 6x. Okay. So that is 12 is equals to 4x. X is equals to 12 by 4. That is 3. So x is what? 3. Hence, so your BC will become what? So 3 plus 2, 5. What is your x? So there, so it will become 5. Getting it? Any doubts? So this is what we are using, the basic proportionality theorem and the similarity here. Okay. Now, the next question that we have here is what? We have a triangle. Fine. We have triangle and two perpendiculars. Okay. So the product of BE and AC. What is BE? BE is perpendicular into AC is base. Okay. So now here also what you see, BC is what? Base, and AD is perpendicular. AD into BC. What we can take? If I want to take the area of, let me take area of ABC is what? Half into base into height. What is that half? Base is what? AC into. So what is that? Your perpendicular is BE. Okay. If I take area of BAC, if I take, that also is what? Half into base into height, which is nothing but half into base is what? BC into height is what? AD. But we know that we are referring to the same triangle, this triangle only. Both the triangles are same, but they have different heights and different bases we are considering. But no matter you take different, see, any triangle, yesterday you would have learned, so any triangle if you see, so you will be seeing that it will be having three perpendicular heights. This is one perpendicular height. If we are taking this perpendicular height, then this will be the base. Okay. If I take, so this as a perpendicular height, this will be the base. Okay. So now if I take this as a perpendicular, this one we did, this one we did. If I take this as a perpendicular height, this will be the base. No matter three, definitely for every triangle we'll have three perpendicular heights and three bases. Okay. So it means what? No matter what the base and what the perpendicular is, overall area will be same, isn't it? So therefore, I can say that triangle ABC's area is same as triangle BAC. So that means if I cancel, if I equal them, if I cancel half and half, so you will be seeing that AC into BE is equals to BC into DE. So that means these both are what? Equal here, isn't it? So don't you think that these both are equal? They are very much equal in this case. So now, so I hope understood here. Now, let me erase these things and let me do the another one. Guys, I'm not getting answers. Like you people verbally, in the verbal class, you guys present the answers, but here you guys are not presenting the answers. Please give a try. So until and unless you don't give a try, you will not understand what is happening. Now, this is one more. In the figure above, so what is the length of side AB? Okay. Here they are asking what is the length of side AB. Guys, how can we find this? How can we find the length of, so this one? So we saw that this is the perpendicular height. What did we see? We saw that this is the perpendicular height. If this is the perpendicular height, let me take this as D here. Okay. Now I'll consider this. What is that? A CDB triangle. I'll consider CDB triangle. So that what I'll get? I'll get this part. See, if I get this part, then I can get this part also. Now, if I get this part and this part, this is also 90 degree. I can use the Pythagoras theorem and I can find this AB here, isn't it? So therefore, what we can do here, so we can take it as this one. What is that? So let us take the Pythagoras theorem. This is 90 degrees. So therefore, we can see that CB square is equals to CD square plus BD square. Okay. What is CB square here? 3 square is equals, 3 square is equals to, so CD we need to find CD square plus, so what is DB square? Root 5 whole square, isn't it? 9, so, and so is equals to CD square plus, so this becomes 5. So which is nothing but CD square is equals to 4. That is CD is equals to 2. So what is CD here? This is 2. If this is 2 out of 10, this part is 2. That means this part will be what? 8 here. What is this part? So this part is 8 and this part already we know root 5. Therefore, AB square is equals to what? 8 square plus root 5 whole square. That is 64 plus 1. Okay. So what we'll be getting? 64 plus 5, that is AB is equals to root of 60. Okay. So what is this? AB is equals to root of 69. That is what we get here. Getting it? Any doubts you people have? Any doubts? Okay, fine. Now, one more thing. See, we are using only what? So the basic triangles, the similarity, congruency we are doing. See, let me name it A, B, C, D. Okay. So now what we have, they are asking for the length of the side AB. But we have nothing here and here and here and here. So we know that this is 90 degree. If this is 90 degree, this is 45 degree. That means this also 45 degree. What does that imply? This imply that this ABC is a isosceles right triangle. So isosceles right triangle means two sides are equal. That means even this side is equal. So what we can do, let us find out BC. We use the same Pythagoras theorem. BC square is equals to what? AB square plus AC square, which is equals to x square plus x square, which is equals to 2x square, which implies BC is equals to root 2 times x. That means what? This is root 2x. So, but here also we have 45 degree. That means this also will be 45 degree. This is 90 degree. So that means this side also will be root 2 times x. So now we need to find the hypotenuse. So what is CD? CD square is equals to, so root 2x whole square plus root 2x whole square. CD is what? 10. That is 10 square is 100. 100 is equals to 2 times x square plus 2 times x square. So that is 4 times x square. So divided by 100. So 100 divided by 4 is equals to x square. So 25. So x is equals to 5. What is the value of x? 5. Getting it? This is again what? Simple Pythagoras theorem. Just understanding it is isosceles, right? We are just taking the sides, okay? We say na angle is opposite to the side. So just in the same way, we have taken this and we have approached this thing. Getting it? Any doubts here? No, right? Okay. So now see, we have, let me name it, okay? A, B, C, D, E. Okay. I've just randomly put this one. What we need to do? So we need to, this one, what is that? Find K here. If we have to find K, so what we are supposed to do here? We need to make sure, let us find this one. What is that? This BD, because it is again a right triangle. So it implies what? 13 square is equals to 12 square plus x. I can take this part. Only this part is x. So now you will be seeing that 169 minus 144 is equals to x square. Okay, which is nothing but how much you are going to get here. So in this case, tell me guys, how much? 125 is equals to x square, x is equals to 5. This is 5. In the sense, this will be what? 7.2. Why? Because the total length is what? So 12.2. In this, it is 5. That means what? The remaining part is 7.2. So now what we can say, if you see the triangles here, okay, so this and this, you can see this and this. So because they are this one, what is that? Similar. The two triangles are like similar because you can see the way it is given. Okay, so therefore what you can say, we can say AE by ED is equals to AB by DC. That is AD. Sorry, AD. This is AD. So AD is what? 13 by K is equals to 12 by 7.2. So this implies K is equals to 13 into 7.2 divided by 12. 12 and 13, if you take 1.08, you'll be getting, when you multiply this, you will be getting around 7.776, which is nearly equal to 7.8. So K is what? 7.8. Getting this? Understood? Any doubts you people have? Just one second. Okay. Guys, understood here? Okay. Any queries you people have? Be careful when you people are doing, even in spite of knowing the concepts, everything. Sometimes when you're doing this one, what is that I can say, BPT and Thales theorem, you people may get little confused. Be careful on that particular part. Okay. So yes. So any other queries or any other thing that you people have? Tomorrow we'll be doing polygons and quadrilaterals. Okay, so we'll be discussing both polygons and quadrilaterals in detail tomorrow, and we will be working on few problems as well. Okay, right. Any queries you guys are free to ask me. And also I strongly recommend for you guys to, what is that, uh, answer the question, try and answer the questions. Okay, so until and unless you don't give the answers, you will not come to know where you're getting stuck, why you people are getting stuck. And quantitative part is that, so which will be very, 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 very useful to get the perfect score. Imani, you can refer to Arun. Yes, this one, Arun Sharma's book, Quantitative. It is like he gives in detail. Everything in detail you will be having. Okay. So, but that's a good series you can take it as. Arun Sharma ka book. Okay. So that's the book you people can refer. You'll have just in and out, and you'll have lots of this one also. What is that? Practices from this one. What is that? Easy to difficult and hot questions also you'll be. It will be having all the right from basics to the applications will be having. And in math, this one math, always remember, it is not the basics that can help you to get the score. Along with the concept clarity, you people need to know applications and their roots. For example, Pythagoras theorem, if you take, okay, if you take Pythagoras theorem, how did it come? Or what is the basic thing that you people see here? If you see, if you would have, if you remember one thing, when I did arithmetic, I was talking about squares. Squares as a nature, okay? Squares has that feature where one number square will be equal to the sum of the other two number squares, okay? This feature and our Pythagorean theorem both are one and same. Observing this nature of the numbers, square numbers, so this Pythagorean triplet also got into existence. Okay, so therefore, what Pythagorean triplet and the squares property, that one number square will be equal to the square of other number squares, so that will be this one. What is that? We can relate like this. They are all interrelated roots, I can say. So math also has some root, okay? Each concept has a root, and each concept is applied also. So these things you people need to know when you people are working on, because in our GRE exam they are not testing your concept. Definitely, that is not so very basic. They are testing so how you can relate your math idea to the situations when it is applied, okay? So how these things can be you understood, or how you people are realizing those things, that is what they will be testing, okay? So therefore, please don't just work on simple things, work on harder parts, so that what happens, and increase your speed also, and this is the part where you can get perfect score. And I guess all of you are more or less science students only, because going for MS, so it implies what? Science students. So science students should have good math, so take that as an advantage and get complete score on them. Okay? So right, any other doubts you guys have? Guys, do you have any other doubts? Is that fine to wind up the session? Okay, guys. See you tomorrow in the class. Bye. Take care.
Thank you, ma'am. Also, if anyone has any doubt related to the Ubergrad website or the handouts or recordings, you may ask now. Otherwise, I'll be ending the session. Thank you so much for attending.